welcome everyone. Thanks for joining us. So we're here to hear from Dr. Willie Rockland. He's the chair of the physics department at Morgan State University, and he did his well, you'll hear all about his path, but he got a BS in physics from Grambling State University, and he earned his PhD from Georgia Institute of Technology. And he's done many wonderful things over the years for the physics community, and we're going to hear from him all about his path. And so we're very excited to welcome Dr. Rockland as our first speaker of our Human Side of Science speaker series that we're hosting. We're co-hosting with the Humanities Center, seeing how science and humanities can come together. So without further ado, let's welcome Dr. Willie Rockland.
Hello, everyone. Hello, everyone. Thank you, Dr. Anderson. It is always a pleasure, and also your entire department and a good friend of mine, faculty Greg Severn, for this invitation to just share with you a little bit about me, my unusual path from football to physics. And I'm focused a lot upon, just my pathway and things like that. And I'll do my best to leave a lot of time for us to talk. So I'll just move forward. Again, thank you for the introduction. And it's kind of funny doing these presentations where you're looking at the screen and you're looking at the people and you don't know who you're looking at. But anyway, I'm going to just move forward with this. It's funny that I can change my my age, just by doing one thing, remove my cap. Yeah. and so I am going to move forward. This is my unusual path to physics. I like to start off with, first of all, over the years now, I've come up with my formulas to success. Of course, you don't normally figure all this out, but you kind of sort of piece it together. And so over the years, I kind of pieced this together, and I hope it comes up. Oh well, it's supposed to be a summation sign. P is equal to a summation of piece of n. And these are what the piece of N stands for: purpose, passion, problems, and also people. And in each one of those cases, this is what kind of sort of I've evolved on pretty much my formulas to success. And I know success is a broad term, and you can kind of define the way you want. Pretty much my definition of success is to really be the best that I can be under the circumstances I'm in. So each one of I look at this over and over again. The purpose, why am I here? Am I fulfilling my purpose of my existence? And then my passion, meaning like, am I doing what I was wired, my giftedness to do? Okay, am I doing that? And I'm having fun doing this. I'm passionate about it. And then the problems. What problems have I faced along the way? Which means to me, problems are challenges. What challenged me, challenge you to grow, to succeed, right? Challenges bring about, problems bring about resistance, and resistance helps you to grow. Depending, whether it's positive or negative resistance, the bottom line is it helps you become stronger, it helps you to grow and to work through. So all challenges you're not necessarily going to say solve, but from out of each challenge, you should have grown and move forward towards your pathway to success. And then last but not least, I look at all the people who help, who help you to grow, who help you to glow, and who help you to go, right? Because you got people who helping you in your foundation, preparing and helping you with your knowledge, and then those who help you to glow, those who help you to illuminate, help you to come out your box, to come out your comfort zone, and then of course those who help you to go, that really move and get things moving and shaking in your life and things of that nature. And I'm going to share with you those 4 areas in which they're related to my unusual path to physics. But let's start off back in high school. Oh, man, I laugh every time I see this guy. That's me with the circle, number 42. I was a running back in high school at South Terrebonne High in Houma, Louisiana. Houma, Louisiana is a major city. Well, last major city below New Orleans. They say the last major city before the Gulf. And I was raised as our high school mascot was the Gators. You know, we were the South Terrebonne Gators, and I was a star running back. Also kind of a receiver too. Well, receiver in the sense of a flanker. So I had multiple skills, and I was pretty good in football. My desire was to be a professional football player. Okay, you know, that's what I wanted to do. I mean, hey, that was my desire. I wanted to play in the football there. I followed all the big teams. My favorite team at the time was the Dallas Cowboys, Roger Staubach and Drew Pearson and Tony Dorsett, you know, things of that nature. And I kept up with the other greats like Franco Harris and John Riggins out of Washington Redskins. You know, I always was following. I kept up those things, but I was real good in science, math and science. And so my mom, I'm also I'm number six of 8 kids. Okay, my mom and dad. And though my mom and dad divorced when I was young, I was 4 years old. That could have been seen as a problem, but it was a challenge. And I just, you know, my mom moved us all to Houston and then moved us back to Louisiana when her mother took sick. But nevertheless, I grew up in this environment where, you know, athletics was my biggest thing. I was pretty gifted, had quite a bit of D1 schools offered me scholarships, athletic scholarships to come play football, LSU, University of Houston, Duke, and other D1 schools. But I had a love. I wanted to play football. At Grambling State University. Okay, I wanted to play football there, and under the legendary coach Eddie Robinson. That was my goal. That was my goal in life at the time. Like here, one of the scenes when I was playing my senior year, looked like I was scared of that guy. I think I pretty much was. I was trying to make sure that none of them hit me. I wasn't a very big.
No, we're not just cranking out things.
Can someone mute? Somebody's not muted.
Oh, okay. I thought I had a question. Okay, good.
Unless.
Good. And thank you.
And yeah, so, if somebody does have a question, you can raise your hand. And I can call on you. Perfect.
So as I was saying, you know, in high school, being a senior, one of my senior games against one of the other top teams. Then here down, this right here is not me, number 42, but it was a good friend of mine at Grambling, at college at Grambling. I forgot his name, Dwayne. He went on to play pro ball, but I wanted to get his numbers. But anyway, he was a starting wingback at Grambling at the time. I went and walked on and made the football team as a walk-on in my freshman year. Though all I had at Grambling, all they offered me was a academic scholarship in physics, because I had some pretty good ACT scores or whatever. But I wanted to play football, and I had the skills, I had the speed. I was running the 4.40 in a 40-yard dash, and I had this, nice size. I was about 175. So I was a nice size, about 5'10", 5'11". So I had everything it takes to do pretty well. But the scholarship is what kind of threw me to Grambling, and I wanted to play for Coach Robinson at Grambling anyway. So I went on to play, made the team, went out, walked out in spring training, made the team. Made the team, and guess what happened? I was in my position as a wingback. I was the number 6 on the depth chart. So I was behind all the scholarship guys. Okay, all the guys who had scholarships, I was behind them. So I had to get some time. I had to play against the number 1 defense. so so the coaches can see my skills and all that good stuff. So what happened this time in spring practice, the quarterback dropped back, threw a quick pass to me right across the middle, and the purpose of that quick pass is to catch and outrun the linebacker. Okay, and normally that is the case, but this time this linebacker was almost as fast as I was. Man, that linebacker hit me so hard. Whew. He rung my bell and everything else. It was a true story of collisions, right? And I didn't win that one, but nevertheless, and that made me realize, okay, hey, I can't keep doing this, because football is not paying my bill right now. It's my academic scholarship in physics. So physics, that's when physics started taking more of the upper hand. I had to give up football, gave football up, and moved on into physics because physics wasn't as dangerous at this as football, but nevertheless. And then as I kept going, I started getting more involved into other things in fraternity, joined a fraternity, got into politics, did a little, what they call it, modeling and things like that. I was, considered, everything man in a passion, one of the modeling passions. I mean, whatever they call those things. I forgot. But now it's a contest. It was a contest where we modeled. It was all men, modeling in front of the group, all that kind of stuff. And then I, of course, being running for student government president, a lot of my fraternity brothers helped me out in many different ways. And so ended up becoming the SJ president here, still being involved in my physics, as you can see, had many different challenges. Even in politics, I was well known, but also heavily involved. But I didn't win. I ran for class president, sophomore class president. I lost in the runoff to a good friend, but I stayed involved. And then as a junior, I ran for junior class president and lost that in a double runoff by 2 votes. To another good friend of mine, we friends now, we've been friends. And then when I got my senior year, I wasn't planning on running. I was going to just go ahead and graduate. But a group of my friends came together. Willie, you really need to run it because you're still familiar with everything. I said, but I never won a contest since I, ran. And they said, well, don't worry about that, man. You got the experience. We here with you. We support you. Let's do it. So, talking to a few more others. Ran for SJ president in my senior year, and voila. Okay, I became the student government president at Grambling. At the time, we had a student body of a little bit over 6,000. An undergraduate body, we had both graduate and undergraduate, but for undergraduate, we had about a little bit over 6,000 students. But the 2 key people up in this paragraph, in this photo, the photo down low, is who were 2 great mentors in my life. Dr. Thomas Odom, he was a department head at the time, and Dr. Jethro Terrell, he was my academic advisor. Dr. Odom, we used to call him Dr. 2, because his initials, his name of his initials is TWO, Dr. Thomas William Odom. So we just call him Dr. 2. And he was the one who, him and Dr. Terrell, great mentors in my life, especially as an undergraduate, encouraged me to be involved, develop all your skills. They were one of the ones that helped me to grow, glow, and go. And that's what I did in many, many cases. And then it's prepared for me to go into the next stage, is which I didn't know what I wanted to do. I didn't think once I finished undergrad, I was thinking about just getting a job. I had several internships at Bell Labs at the time in New Jersey. Fact about it, my 4th one, I met my lovely wife in the summer of '89, and she was in math and I'm in physics. So like I tell everybody, tell all my students, math and physics is like husband and wife. So, hey, can't do the physics without the math. But anyway, and so once I moved from there, this is a kind of a wrap up of my education. I did my BS at Grambling, finished in '88. My first master's at SUNY Albany in New York, due to the champions in my life at every stage, Dr. Odom, Dr. Terrell, they kind of coach me and say, you know, I thought I was ready to go into a high power. Well, I didn't know if I was ready. I didn't think I was ready to go in a high power program, even though I received a full graduate fellowship from Georgia Tech, MIT, and Stanford. I still got a copy of those letters. But I didn't feel internally that I was ready, even though, you know, and so Dr. Odom and Dr. Terza would really consider another school that would definitely get you prepared. If you don't like it, you can always, you know, transfer. So I went to SUNY Albany because I was more interested in lasers at the time, and met some new champions who were mentors to me. Dr. Yolanda Nix. She was not even a scientist. She was a social scientist, but she really recruited us and mentored us in a support system while I was there. Because I'm, you know, a Southern Louisiana boy, way up in the cold aspects of Albany, New York. Okay, and so she made sure that I, you know, had interaction of a community where I was able to interact and still have a sense of family, even though I was miles away. Then Dr. Kimball and Professor Carolyn McDonald, they were two of the major academic champions for me in the physics department, really coaching me through, really making sure my mindset was in the graduate point of view. Did my master's there, and then went on. It was just too cold for me in Albany, New York. Okay, it just was just too cold. Ironically, I'm now back up here in Baltimore, almost close to Albany, but nevertheless, transition from Albany, New York, back to the South, deep South, in Atlanta, Georgia, at Georgia Tech. The official name of Georgia Tech is the Georgia Institute of Technology, but many people just know it so much as Georgia Tech. And so, because I've had people call it Georgia Tech University, but nevertheless, that's what I had. A couple of other new champions. One, the department head, Dr. Henry Bonk. He did a very unusual experiment that proved to be made great strides in underrepresented minorities getting PhDs in physics. What he did during the year I transferred to Georgia Tech, which was 1990. He recruited 5 African-American students to receive graduate fellowships at Georgia Tech the same exact semester, which was the fall of 1990. I was one of those 5. And it was 4 males and 1 female, Zelda Gills, she was a female. But we all came from different universities. Most of us came from historically Black colleges. One student was actually did his undergrad at Georgia Tech, named Kenneth Brown. And that guy was, man, he was phenomenal. Very athletically inclined and extremely smart. But anyway, we all went through, and I didn't pass my qualifiers the first time. You know, I like to tell the story of students, you know, you're not going to always get it on the first time, but that shouldn't stop you. What my other 4 champions for Georgia Tech, Dr. Brian Kennedy, he's full professor there now. He helped in his electromagnetic class. I didn't pass my first qualifiers because at Georgia Tech, you were doing 5 areas over 3 days. And you come in at 8 o'clock in the morning and take your comps, and you leave at 5 o'clock that evening. And it was on all undergraduate physics and first year graduate level physics. And so the first day was classical mechanics with a little thermodynamics. The second day was electricity and magnetism with a little bit of statistical mechanics. And then the third day was quantum mechanics with a little bit of something else. I don't know that was, but I did well on day 1 and day 3, but day 2, when I got to E&M, I went blank. My mind just went blank. And but I did good with the statistical mechanics. And to find out, I passed 4 of the 5 areas. And so they were like, hey, you passed 4 of them. You can do them all over again. It's just 1 more. So I had to study for all 5 of them again and be prepared in about 6 months. And Dr. Kennedy's class is when I had my my come to Jesus moment in electricity and magnetism when they all made sense. I was sitting in 5 different E&M sections, 2 graduate level and 3 undergraduate level. No, 6. I had a total of 6 because it was 2 graduate and 4 undergraduate sections of E&M. I was sitting in there just making sure I'm going over the information. You know, I was taking notes again and again. And in one of his undergraduate E&M is when it's like the urethra hit me. Boom! It just, all of Maxwell's equations just started making sense. Gauss's law, everything just started making sense. Wow! And then went and took my qualifiers again and passed it with absolutely no problems. But it was a learning experience. You know, it was a problem that occurred in my life that it was a challenge for me, and I had to ask myself, well, I was going to get into that problem, or well, I was going to give my very, very best, and then at the end of that, if I made it, great. If I didn't make it, at least I would have been able to say that I gave it everything I had. And so as you can see, I proceeded forward, continuing on through my PhD, where my other champion, Dr. Donald O'Shea, who was my advisor in optics, which formed electricity and magnetism, and then Dr. William Collin, who was over in electrical engineering, because I had my minor in electrical engineering. So I'm gonna move a little fast because I got quite a bit more. So as I think about it, when I come to my research, well, my experience is I had quite a bit of experiences, but a lot of things was going on in my life. It just seemed like I didn't have a simple life. While I was at Georgia Tech, I also was in the special program and for the Air Force. So I was technically a research physicist for the Air Force. And I was stationed at Eglin Air Force Base in Florida. But then also I got my call into the ministry. Okay, I'm also an ordained minister, ordained Baptist minister, and I served as the senior pastor for this church in East Point, Georgia, one of the suburbs of Atlanta, for 11 years. So while I was still, doing things with the Air Force, I was also serving as a senior pastor minister, dealing with all the dynamics of that. And I was still in graduate school in the back part of my PhD program at Georgia Tech. And then, of course, made a transition from Georgia Tech all to Eglin Air Force Base for a few years. And then while I was there, physically, I was, got recruited by Morehouse College in Atlanta. Also, is an all-male HBCU, historically Black college, all-male, private all-male college. In fact, is the only all-male college that with a mission for African-American, educating African-American males in the entire world. There's just not another organization, another institute that's focus is on educating African-American males. So I was there for about 20 years, going up through the tenure ranks and everything. Of course, in some of those years, I was serving as a pastor of Divine Unity for a while, and dealing with all those dynamics, coupled with raising a family. My wife and I have been married now almost 29 years, and we had 7 children, 7. And so, I just always had a lot of things going on in my life, and that which is good. It was good for me because that helps me to stay focused on other areas, knowing that I had a few other things, other major things going on in the pot of my life, in the fire of my life. And then in my last few years at Morehouse, I served as the department chair for physics and the dual degree engineering program. DDEP stands for Dual Degree Engineering Program, which was number one producer of underrepresented minorities in physics in the nation, and by far. But nevertheless, so some of my success came out of that, working as a team with the faculty and everything. We really pulled things together, which led me to my current position for almost 3 years now as the professor and chair at Morgan State. And we're really doing some of the similar things, but relative to our dynamics here in Baltimore. I'm now at a more a public institution, co-ed, and that has also a graduate master's level program too. So got a little more growth and dynamics, even though position wise as department chair, it seems to be more of a lateral move. Now, research. My research started off initially in diffractive optics in the visual regime, and then it expanded through my collaborations to the extreme ultraviolet side, and also terahertz imaging. So it's pretty much those regions right there you see is where I work, anywhere in between. And so that's pretty much my area is now nanolithography, where I do a lot of optical design and fabrication of optical elements for different optical systems. But my current, my current research collaborations, of course, my own laboratory here at Morgan that I'm re-cranking up, and I'm working with Dr. Thomas Searles at Howard University and a couple of my colleagues still at Morehouse on some terahertz photonics, where we're looking at different phase change materials. And then, of course, some terahertz imaging with one of my former students under his advisor, Dr. Jay Matthews at the University of Dayton. I did some great research with in nanolithography and extreme ultraviolet EUV nanolithography with a good colleague in electrical engineering at Colorado State, Dr. McConey, and the EUV ERC team. So, but one of the great things out of all that work since 1998 up to this point, had over $5 million in research funding. But what I'm most proud of is over 30 of my undergraduate research assistants, over 30 of them, I just stopped counting after a while, have PhDs in STEM disciplines. Many of them in physics and engineering, and you meet quite a bit of them. Dr. Thomas Searles is one of them, Dr. Eddie Red, and Dr. Wesley Sims. All of them are former students in my research lab under my mentoring at some point in their academic profession, academic matriculation. Now, this is why I use for my mentoring, I call it unusual path. I try to always tell my students there's 3 things you need to know as you're going through. These are 3 fundamental concepts I get them to always understand. Your net worth, it means what you know, okay? The knowledge, your knowledge growth, and your knowledge content and so forth. And then your network, mean who you know, as you go into different summer internships, the faculty, professors you meet in your classes, the students you meet in your different classes, wherever you go and interact at conferences and things like that, you're building a network, okay? But the third one that many people forget, which is part of mentoring and part of helping someone to grow, to glow, and to go, is net weaving, okay? Net worth is what you know, network is who you know, and net weaving is who knows you, okay? And some people, you'll get the chance to meet, you'll get the chance to learn of people from someone else you know, okay? And which means also, my students in the audience and so forth, you will get many offers and opportunities through a third-party source. I mean, the person who's approaching you don't quite know you, but they know you have mutual friends. You have a mutual collaborator. You may have a mutual a mentor, okay? So it was also who knows you. So that's why I encourage all of my students. I go to conferences, make presentations. Yeah, make some mistakes. So, okay, so what? We human. To human is the error. We make mistakes, but it's also, you get a chance to meet people, and people getting a chance to meet you and your talents and your skills. So I always encourage them to continue to net weave, keep weaving your network within other people's networks, and you'll find out who knows you, and people, you find many more opportunities come forward. So that's one of my unusual paths that I've learned in physics, is the mentoring, and that's something I heavily do quite a bit. Some of the results are just this. I had a chance to start this map when I was at Morehouse, and I'm continuing now even here at Morgan, that I've sent students to REU's research experiences, and I think in almost all of the continental U.S. I've got a couple of states I just haven't gotten to yet, and one is North Dakota, and the other one is Maine. But you know, I encourage my students to try to go to different research experiences across the nation, okay, and different areas, and they're none out of their comfort zone, because I try my best to always encourage my students that, hey, you can live anywhere during the summer in the United States for anywhere from 6 to 12 weeks, okay, and get paid, which is great, okay. So those are some of the things I always encourage students. So in this so far, I have a little map of, you know, of some of my accomplishments, some of my students. Many of them go to these places several times, but I just at least mark it down at 1 or 2 different spots in that particular state. I haven't got anyone in Hawaii or Guam yet, but I think that's coming soon. And then likewise, I kind of use this as my formula of success is the purpose. I understand why I'm here. My purpose is clean and clearly, though I got an unusual path. I got into physics from an unusual path through football. I've always found, I understood that my purpose is not only in learning more about physics and doing more physics, but it's also is to helping others to find their purpose. Hopefully in physics, or whatever it is, that's part of what I do, is make sure it's trying to help others understand their reason for being here, right? If you can get your reason for being here, the motivation is within itself. And so then my passion, I love what I do, and I try to encourage others to love what they do. And your passion can change, and there's nothing wrong with that. Okay, over time, you know, your passion may start off in the area of physics, and it take you into another area, you know, maybe research physics, and it take you into physics education, or it may take you completely out of physics. Okay, but I always say, follow your passion, what you were wired to do, what you love to do. If you didn't get paid 1 penny, it's how you know what your passion is. If you didn't get paid 1 penny, you still will love doing what you're doing. If you can answer that on that thing, that's how you know. Now, if you feel that you can do what you do, but you need to get paid for it, then that's a hobby. Okay. But anyway. And then again, my set is problems. When I meet challenges, and as I encourage others, when challenges come in your life, it's to make you stronger. When you have problems in classical mechanics or thermodynamics or electricity and magnetism, those problems are tough. Yes, they are tough. But like I tell every student, I say, you're not solving any problem that none of us have already solved. The problem is solvable. It's designed to exercise you, designed to expand your knowledge and your application of your knowledge. Okay, so just because you can't solve it the first time you see it, that's all right. Okay, now some problems are designed to develop different aspects of you, like your grit, your how much your tenacity, your determination. Okay, is to get this done, and that's what happened to me especially when I had I had to take the qualifiers, my doctoral qualifiers, PhD qualifiers the second time. It forced me to really focus upon, do I really want to do this? Okay, and so I had to knuckle down and block out a lot of other things in my life and focus on just preparing for that. And then once I cleared that hurdle, then I reopened my life to a lot of other things. But challenges come to help you to grow and succeed. And then last but not least is people. People, we all need people. No one is an island by themselves. We all need people. Now, some of us may need more than others, but nevertheless, we all need people. And there are people who will come along your pathway, your journey, who are there temporarily. Some of them are there just for that particular season. some of them there for your entire life, you know, and so, but but what those people come to as mentors is to help you to grow in whatever area you're dealing with, and they'll help you to glow, to illuminate, to become confident in that area, and then of course to go, because the purpose of growing is not to stay still. The purpose of growing is to go and to spread and to share. And so that's my little formula for success, if I had to give it to anyone. But that's just a wrap up of my talk, my unusual path into physics, coming from football. And so thank you very much for your time. And I am open for any questions.
Thank you so much, Willie. That was wonderful. Thank you. Okay, so who has questions? I see a hand up from Brandon.
Hi, Willie. Thank you for joining us today. I had one question about if you had one piece of advice for someone graduating, or something you wish you knew when you were graduating, what would it be?
Oh, for some, wishing to do we graduate? Well, that's a good question. It's just that when it depends on, you know, your interests, on where you want to go. And if you don't quite know your interests, like I didn't quite exactly know what I wanted to do. Once I fell into physics from football, I came to a realization that there's two ways of finding out what you want to do, at least two ways. But the two ways, one, you know it, you kind of already know. The second way is you start figuring out what you don't like doing. And that way you can also figure out what you want to do. I would recommend somebody who's graduating, okay, look at the experiences you've done already. Okay, if you had any summer experiences or you had any intern experiences and things like that, ask yourself, did I like what I'm doing? Then you ask yourself, okay, I know, talk to a few people about graduate school and talk to other graduate students if you haven't already done so, and find out, like, okay, what's it really like? You know, we as professors, we're gonna tell you, man, we love it, right? Yeah, we've been through it. But find out what it's like right then. You know, it's not easy. Graduate school is not easy. It's tough. And but you gotta ask yourself, am I ready to focus down for a few years? And remember, you know, graduate school is not gonna last forever. Okay, it's only gonna last for a few years. When you look back, you're gonna realize that, oh man, it went by pretty fast, faster than I thought it did. So please, first of all, look at what your experiences are, and then also look at what other avenues that could be. And then third, talk to a few other people in those avenues already. And it'll help you get at least get a good sense of where you kind of want to go.
Thank you, Willie. And Madison.
Hi, Willie. Thank you for coming to speak with us today. I really enjoyed the talk. I had a question kind of regarding your passions and your paths to get into physics. It seems like you began in college with the experience of kind of in politics with running for student government, and then your interests and passions in theology that kind of like led you on your way as you were developing your career in physics. Do you think that it is really important, I guess, do you think that those really helped you and grounded you and made you like a well-rounded individual in your research in physics still today? Like, do you think that's a really important part to focus on, kind of being, having experience or having passions in multiple disciplines?
Yes. Oh, wow, that's great. Yes. Yeah, I mean, the physics community is evolving. Okay, just like anything. Okay, and we may miss it. When I first got into physics, there were several people who used to tell me that, hey, if you want to do physics real good, that's all you got to do. Don't do nothing else, right? And so I was beginning to believe that, right? But then I stopped doing everything else and I started sucking in physics. You know, I got horrible, man. I wasn't picking up, basic stuff, Newtonian, laws, none of that stuff, right? But then I noticed that when I start doing other things, when I would get involved in the politics, student government stuff, or I would go out and play flag football with my fraternity brothers, or even join a fraternity. When I start getting involved in other things of my hobby and interest now, those other things help me in some way to focus on my physics better. Okay, and now I use this model now. Okay, I'm sharing with you what it took me about 30 years to learn. Okay, the model I call it it's changing your mindset from being like waffles to like spaghetti. Okay, you want a spaghetti mindset instead of a waffle mindset. Okay. I hope y'all had y'all lunch and everything, so nobody's hungry right now. But look, what I mean by that is if you could visualize what a waffle look like, okay? And waffles got little compartments, right? And so you put a little syrup in the compartments and stuff like that. But that's what sometimes we think is that, hey, our life is in little compartments, all right? And they section off and things like that. And that's not quite true, okay? So when you think of a spaghetti, right? Think of a big plate of spaghetti. I hope most people have had a big plate of spaghetti or noodles or something like that. Yes. Okay. I think that's a general one. But think about it. When you got a big old plate of spaghetti and you want to eat something, you take your fork and put it on, say, this side of the plate, and you twist it, right? And now the spaghetti that's near your fork, you can easily see how it's being affected by the twisting of the fork. But then if you look across on the other side of your plate of spaghetti, this mound of spaghetti, you see something moving over here, but it doesn't, you can't quite connect it. You get what I'm saying? Meaning that some things you can connect and some things you can't connect. But if you keep turning this fork, that noodle gonna keep on moving, okay? And it goes on this big old mound of it and it comes out on the other side. So I'm saying that's what happened with our knowledge. That's what happened with learning in different classes, your history, your mathematics, your social sciences, your physics. All that stuff come together and helps you come stronger in your physics, like other activities, like extracurricular activities, going and helping at the homeless center, or doing some stuff that has nothing to do with physics, right? But it then helps you when you come back into your physics world or working on some problem, like, oh yeah, because I learned this is what I learned about myself. When I take my mind off my physics, in my front view, my subconscious is still working on it. And so, and then because one time I was in the middle of a preaching a sermon, and the solution came to me. Like, whoa, now most of my congregants, they thought I was really getting excited. I was getting excited, but it wasn't over that. I was getting excited, like, man, I got this formula. I said, so please keep my memory on that one. Okay. As soon as I finished the sermon, I went to the pastor study and started writing down my notes. And before anybody came in, the deacon come in and say, oh, Reverend, you did a great sermon, blah, 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 blah. I'm like, yeah, thank you. But after that, I showed my wife, I said, baby, look, I got the answer. What I was telling you about this problem, so, but for me now, that's for me, it works, in a variety of ways. And so a key is that you're trying to learn about you. The biggest thing is you're trying to learn about you. And all of us are unique. Now we got great similarities. But we also got some uniqueness that's associated with us. And so you're trying to find out your uniqueness, and that, but many times we've come to learn to make you a well-rounded person. Holistic, it's good to take the holistic approach. And do some other things of interest, and sometimes they may not even be of interest. It may be recommended by your mentor. Okay, say, oh, why don't you try this or try that? Give it a shot, give it a good try. Because even if you don't like it, at least you've learned one thing: you don't like it. You learn that you don't like it. Okay, and so, but you also have probably learned something else that you can keep with you even in that experience. Okay, so that's my basic answer to that question.
Thank you.
Richard. Yeah. Thank you, Willie. Richard, do you have a question?
I do. Willie, you've had an incredible experience in your career path. It's absolutely fascinating. Let me ask you, what lessons have you learned as an athlete involved with competition that spurred you to be successful in other areas?
Give me that first part of that question again.
Yeah. What lessons have you learned from being an athlete
Okay.
and having to engage in competition that has helped you be successful in other areas?
Oh man. Well, being an athlete, what I learned in biggest is that, I mean, in the greatest sense, being an athlete, you know, that they are transferable skills. I try to tell all my student athletes, look, the same stuff you do to train for physics, for anything. I mean, I said the same stuff you do, I did for football. I'm like, okay, we had weightlifting, you know, because you need to build your strength. You need to build your speed, right? And football is strength and speed, okay? And a little finessing, but that comes, you got to practice. I say, so you go to practice. You go to weight training and exercise that helps you. I say, those same technique, I end up taking that same kind of technique and approach to my physics, even when I was in undergrad. You know, I was like, okay, well, if I'm practicing a lot, then I need to practice some problems. Okay, if I'm gonna get better at this classical mechanics, you know, this up, I got to work on these Newtonian ways and look at the Lagrangian and Hamiltonian and blah 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 blah. Okay, I'm practicing myself, you know. But then also I realized too, from a competition point of view, the competition wasn't with others; it was with me. I started realizing that I'm not competing against somebody else. I'm competing against me. I'm competing against Willie as a freshman this year to Willie what Willie want to be as a sophomore this same time next year. And to look at that and try to make some measurements, some goals along the way and see if I'm achieving them. And then even if I'm achieving them, so were they easy? Or did I have to really work for it? Did I stretch myself too thin? You know, or did I wasn't really give myself my best? You know, I had to start doing a lot more inner reflection so that I can become a better person, right? And become a better Willie so that I can be in a position to be competitive, not necessarily with someone else, but to be competitive. And then even when I am competitive with someone else, I was in a position to be more of a friendly competitor. A helpful competitor. You know, yes, I want to score more than you, but hey, I would, if I'm gonna lose a game, this is what I used to say, if I'm gonna lose a game, I want to lose it by 1 or 2 points, right? I want to, if I'm gonna lose a Super Bowl, let me lose by a field goal or a touchdown, okay? And you say, well, why you want to do that? Well, if you lose at a smaller, you know, yeah, it's more heartbreaking, but it also lets you know that you gave it your best to a good degree, and that team just happened. The time happened to be on their side. Some things I had no control over. Okay, but it lets me know, hey, you know, I wasn't so bad out. Now they beat me by like 4 or 5 touchdowns, like you know, like Alabama did to Ohio State. It was obvious who number 1 was. So I would rather be in the hunt where there's a chance that okay, he could have done. He wouldn't have fumbled that ball. You know, he had a better chance, right? Some of that nature. So that's just my perspective on it. But I also like helping when you become more competitive. So variety of things in being an athlete. And I really say it's not even being an athlete. It's being committed to doing something that you really like. Okay. Some people think you have to. You know, it's obvious from athlete. Well, if you cooking and you love cooking and baking, you know, you are meticulous. You pay attention to detail. You got to put in just the right amount of salt and, you know, the right ingredients, and you're looking for the certain kind of flavor, right? Take those same skills and put it in your physics, you know, because that's what we look for in physics. We look for anomalies. We look for stuff we look for the usual stuff, but we also look for something that give you some new stuff to look at. All right, so same skill sets would go a long way. Just that try. I tell students, try your best in whatever you do religiously, whatever you love to do. Okay, try to understand those skill sets you're learning, and then take them and apply them into other areas of your life. They are transferable skills, because the only common denominator in everything you do is you. So, hey, if you got the skill set and applied over here while I was cooking, or applied over here while I was playing ping pong, or applied over here while I was just picking up trash in the street, I can use that same skill set in my physics, in my studies, my academics, in my research lab, in my family life. I can use the same set of skills. Hope that answers your question.
Thank you, Willie. I also saw Laura and Greg both had their hands up, but they're down now. Were your questions answered?
Well, I'll put mine back up. So I guess I'll just blurt out a question. Thank you so much, Willie, for coming to talk and sharing your experience with us and your path and the things you've done. I've just been impressed over the years what a great leader you are, an academic leader, a department chair, doing all those things, but you've been a leader on the national level too. And I kind of wanted you to talk about that, but my real question is this: when I saw that number, 30 PhD students that you've begun to mentor, and they ended up doing that, I was thinking, wow, you're better than some whole departments at that number. And I'm thinking, are you writing a book about how to mentor? Are you trying to put, what are the highest impact things that you've done? I recognize your whole talk in some sense is an answer to that question, but what are the things that have been most impactful for those 30 students as you've been mentoring them over their track? And the second thing is, those 30 students, did your relationship with them extend over that whole track? Were you checking in with them after they had left you as in their undergraduate work? Were you checking with them while they were still graduate students and so on? What was your track with mentoring them?
Okay. Yeah. Well, thank you. First of all, I'm still counting. Okay. I didn't, and just to give you context of what happened, I got nominated for the presidential award in excellence for STEM mentoring. Okay. For STEM mentoring. I forgot. It's PAESMEM. Okay. I got nominated for that for 2 years in a row. And this year, I was trying to put forth some more energy to apply. I mean, when you get nominated for an award, but then you got to do so much stuff to apply for it. And like, if you want to accept the nomination, I'm like, wow, why don't you just give me an award? You think I don't, deserve it? Just give it to me. That's what we used to do it back in the day. But okay, I understand. We change, evolve, whatever. But nevertheless, so while I was preparing for this, and a couple of team, a couple of my former students and an assistant was helping me. We ran up on all the, they tell me to go back on all my files and stuff like that, and to pull up the students who who was your undergraduate research lab, and you mentored directly and all this and all that. And I was like, wow. I said, wow, I did all this. I mean, I shocked myself. And so we've been accumulating the names and people and things like that, and we're well over 30. Okay, and so it really is a much larger number, but I just wanted to give you a number that I knew I was sure at. So that's really the floor. But then I started looking at it. I said, yeah, I know on most of these guys. So soon as I saw their name, bam, I just started telling them what they were doing, because most of I stay in touch with. I consider them as my academic sons. Okay, my academic sons and daughters. Okay. I come from a large family. I told you all that. I'm number 6 of 8 kids. Okay, my mom and dad. Okay, but my dad is number 8 of 8. Wow. And my mom is number 6 of 23. Okay, So I am used to a very large family. I'm used to a family concept. And even me and my wife, we have 7 children, okay? And our youngest is a senior in college right now. You know, I'm glad when she graduated, you know, get out of my pocket. And so I take on all my students as my sons and daughters, okay? And I keep in touch with them as best as I can, and we, especially their first year of graduate school. That first year of graduate school, I tell every mentor, you mentor any undergrad and they go into graduate school, you need to be in touch with them at least twice, possibly 3 times. I said, in the first semester, you need to be touch base with them at least twice, probably 3 times, that first semester. That second semester, you touch base with them once or twice, okay? But that first year, you need to be in touch with them because, graduate school is a beast. Because they transitioning from, hey, I'm hanging out on university, I can go to my department, I go to a couple of classes over here in social science, I go to classes over here in economics and business. No, when you go to graduate school, you go into classes only in physics. That department becomes your home. It becomes your, and so making that transition sometimes is very difficult. So I always stay in touch with myself, and I stay in touch with them, even at we go to conferences or things like that. My relationship with them has evolved to where they're not just my academic sons and daughters. Now they're my colleagues. And in some areas, they're my mentor. Okay, so I bounce things off of them. I say, what about such and such, right? And because what I try to do, I try to establish a strong family relationship with them. And yes, they come talk to me about non-technical stuff, right? They talk to me about stuff that's personal, and I keep it that way. And I share with them, some of my personal challenges too. I don't want any of my students to ever think that I'm Superman. Okay. Yes. My name is Willie S. Rockland, but the S does not stand for Superman. It stands for Samuel. I am a regular old fella. Okay. So I try, but sometimes I know when I was coming through, my professors to me seemed like they were like demigods. They were just so smart. I assumed that they made nothing but straight A's in all their physics. They had no challenges, and stuff like that. So, but after we got the chance to know each other more and stuff like that, they opened up and shared with me. And I always encourage faculties and colleagues, hey, stay in touch with them, especially that first year, because after they get through that first year, then they start tapering off rapidly, and then they are well on their way. And then at the same time too, don't be afraid to let them know as an undergrad, some of your challenges that you got stuck at, and when you were undergrad or when you was in grad school and things like that, and let them know that you human, you're human. You're not a demigod, So I hope that helped.
Yeah, thank you.
Oops. Thank you, Willie. Other questions? I don't see any other hands.
I had a quick question, if you don't mind. First of all, thank you. I love that we're doing this series, the human side of science, and I think what a great way to start it off. So thank you to everybody in the department, and of course Willie, thank you for being here. But I was wondering, you mentioned some things, some short lists of, purpose, passion, problems, people, know your net worth, your network, your net weaving, all that good stuff. What of those things do you find that you see either when you were a student, your peers or yourself, or now your students? What do you find that people lack the most that, transfers into their future career? Of those things, what do you think is the biggest struggle generally for students that you've seen?
Well, let me, Laura, thank you very much for that question. That is a very insightful question, because what it makes me do is makes me look over, well, a little bit tell you my age, but at the same time, kind of look over a range of years to, because that answer has evolved. Okay, that's not a constant answer. And again, I want to get this out before I forget, because my age is coming to bear again. Again, thank you again, Ray, Anderson, and Greg. This is my second interaction with your department. Okay, my first one is when I was serving as a national president for Sigma Pi Sigma, and I came out and did a Sigma Pi Sigma induction, and I sure was hoping to be in sunny San Diego right now instead of in this snowy, wintry mix here in Baltimore. But we understand.
Hopefully next year.
Hopefully next year.
Hey, I'll take it from that. Okay. And so thank you again. But that question has evolved. When I look at my students over the year, and I even look at myself. When I went into undergrad, my challenge for my generation was net. Okay, it's three. You got net worth, and your net weave. My challenge was my net worth. Knowing the knowledge, knowing what you need to know. Okay, and now all of us, all those parameters are based in them, but just like one of them seems to lack more than the other. And I think that was my area for my generation. I saw another generation come behind me, and theirs was more or less net weaving. Okay, they got network down, they got the net worth down, they got that down real good, but they didn't understand how to net weave, how to interact with others who are not necessarily in your network, and notice that their network's going to cross, intersect with your network at different areas and stages, and you may get some contacts or such and such from a third party that you don't even know, but y'all have a mutual collaborator, a mutual friend, or a mutual person who met you or something of that nature. Okay, so, but then this current one that I'm dealing with now, my students now, my modern day students right now, their biggest challenge is networking. To me, is that they're very smart. Okay, they're very smart, clever. Well, I'm gonna say smart. I'm gonna say clever. Okay, there's a difference between being smart and clever, and mean that they catch on quickly when they want to. But if the student now they disengage with you, I don't care what you're saying, they're not going to connect with you. Okay, so and what I mean that not that they are unable to learn, it's just that they choose not to connect to learn. Okay, but that's one thing. But their challenge is because of their environment, the gaming system, things like that, the technology, access and all that stuff, is that they've raised up to where they don't necessarily need to have face-to-face interaction. And I hate to say this, but it's a true comment I'm about to say to you. This COVID pandemic has really shook up our younger generation. It's really shook them up to see that I really do need some human interaction, right? And being on lockdown, that ain't no fun, okay? Yes, I need my device. Yes, that's fine. But I got to put that device in context. I also need to have some human interactions, okay? So I need other friends. I need other people I can interact. Even folk who I don't necessarily like, at least have some human interaction. So what hurt them was pretty much their networking. Okay, now they begin to see from this COVID situation, I need to be in tune. I need to touch. Yes, I need to go to some seminars that I'm not going to learn anything. Well, I'm thinking I'm not going to learn anything. They're going to talk way over my head, but I need to go anyway, just for the sake of interacting, one, and to strengthen my relationship and my networking with my department. And I don't know, then I got to start saying, I don't know who I might meet at this seminar, okay? That's my hardest. I'm trying to convince my students, go to the seminar, right? I know it's not, no, I know you're not gonna get no credit, nothing extra credit. No, it's not for a grade. Go to it. You know what I'm saying? But but then when they go, they come out, oh, Dr. Rock, man, I had a great, oh man, that was good. Why you didn't tell me about this? I said, I've been trying to get you to go for the past 3, semesters. But anyway, so I say, because I tell them, I said, you gotta, in order to get some opportunities, you gotta be in the arena to get them. Okay. And sometimes it's being in an arena, right? You don't learn nothing else, but you find out something new that sparks your interest, it catch your attention. I'm gonna follow up on that. And next thing you know it, you got a graduate fellowship. You got a full ride to such and such and such. You got a job working at Lockheed Martin, yeah, right? So that's part of, I think was lacking for this generation. But I also say, I think this COVID pandemic has really brought them around to see, okay, hey, I do need human interaction, all right? So I hope that helped you out.
Yeah, that absolutely answers my question.
Okay.
Thank you.
Thank you so much. So is there any final questions? All right, well, Willie, I just want to thank you again so much for joining us and giving such an inspiring talk. It was wonderful. And yeah, hope to, in the near future, be able to invite you to come give a talk in person.
Yeah.
And believe me, I would love to come. But thank you once again. And as me and Greg continue to work out some great things, your leadership obviously is doing some good things. I have quite a few friends. I've been sharing this concept of the human side of physics, and I think that's a good thing to have, especially for our students, not just our colleagues. We need to we need to know that, hey, everything doesn't happen like we came in there. It's a little different, but I always try to say it's not where you're starting at. And most of the time, it's not where you're finishing, but it's the pathway and the journey, which gives us so much excitement and so many opportunities. So again, thank you for allowing me again to cross with your department and also you crossing in my path. So thank you very much.